Hello everyone, this is going to be a very detailed video, and in this video we are going to study about Redis. So I mentioned all the chapters that I'm going to cover in this particular video, and if you want to study something very specific you can just go there and study. So without wasting any time, let's get started and study Redis. So let's start with the definition of Redis. Redis stands for Remote Dictionary Server. If I talk about it, it is an open source in-memory data store. Open source means that anyone can collaborate in the Redis community. In memory, Redis stores all the data in RAM, and we are going to see that with the help of storing the data in RAM, Redis is going to be lightning fast. Second point is that Redis stores all the values in the form of key value like a dictionary, but Redis also supports various data structures. So we are going to see that what are the other data structures that Redis are going to support, and most importantly, Redis stores the value like dictionary in Python, like a key value pair. Third point is that Redis is versatile. You can use Redis as cache, rate limiter, Kafka, Bloom filters, and many more. We are going to see the applications of Redis, and we'll see that how Redis is useful for production cases as well. Fourth point is that Redis is written in C for high performance and low latency. Major reason because the Redis is written in C because C give lot of leverage to CPU operations. Now let's understand why Redis is lightning fast. So first point is that everything happens in RAM. So let's see the capabilities of RAM first of all. So I mentioned one table. So there are 3 rows of RAM, SSD and hard disk. So let's see the speed. If you want to perform any operation, Redis will take or RAM will take approximately 100 nanoseconds to perform that operation. If you have to do the same thing in SSD, it will take 100 microseconds. In hard disk, it will take 10 to 5 milliseconds. So this is the difference. So hard disks are still in use with some legacy systems. SSD are still in use and everyone is using in databases. But if you want something at very high speed, like if you want to perform operations like million operations in a single second, then of course you have to go with Redis. And Redis will provide approximately 10 million plus operations in a single second. While SSD can also perform like 500 to 100k operations in a single second, that is also a very good number. But if you talk about the hard disk, it will be able to perform only 500, like able to perform approximately 100 or 200 operations in a single second. So it's not that good. But if you want to perform anything very fast, you will of course choose Redis. Just remember one thing, that if you're choosing Redis, you will get a very good speed. But the only problem is, if you want a lot of space, then you have to pay a lot of money for it, because you're getting speed but the space that you're getting on RAM is going to be very less. Now let's move to the second point. So second point is single threaded and event driven architecture of Redis. So first of all, let's understand the single thread. It means that Redis work in a single threaded architecture. So I mentioned, like suppose there are 3 clients, client 1, client 2 and client 3, and there is a Redis. And I told you that Redis are going to store the data in a form of a key value pair. So I mentioned that key is going to be counter and value is going to be 0. So what happens now? Suppose that if client 1 come first, then client 2 and client 3 are going to wait, because Redis is a single threaded architecture. Only one action can be performed and all the other tasks has to wait. So client 1 is going to, let's say, increment the value of this counter variable. I also mentioned counter plus plus. So let's say client 1 is going to increment the value from 0 to 1. So all the other clients, client 2 and client 3, are going to wait at that time. Now what will happen after that? Then the client 2 will going to perform the action, then client 3 is going to perform the action when the client 1 has completed its action. Remember one thing, that Redis is going to follow a FIFO format, first in first out, or you can just say FCFS, first come first serve. Now we are going to see event driven architecture or non-blocking IO. These are both same things. So let's understand it. So what I did, I just put one while loop on all these clients. So let's understand it. So suppose there is a one client, client 1, and it is performing some action on Redis. I know that Redis is very fast and every action will take just a microsecond or a nanosecond, but let's assume that client 1 is taking a lot of time in performing any action. So the client 2 and client 3 are waiting. But if there is a while loop running, so let's understand like a code. if a while loop is running, if the client 1 is going to perform any action, is fine. What will happen? Then client 2 will come and it will check if Redis is free or not. If Redis is free, it is going to perform the action. It will also increment the counter. If Redis is not free, don't worry. What will happen? It will just go back into the queue. The order is going to change because client 1 is still busy. And now what will happen? Now the order is going to look something like this. Client 1, after that client 3, and then client 2. Because what will happen now? Client 2 will go back into the queue because client 1 is still busy. So what will happen to accuracy? Let's understand it. Suppose client 1 is going to set the value 1, client 2 is going to set the value 2, and client 3 is going to set the value 3 in this counter variable. So suppose if the order changes. So first client 1 is taking a lot of time and it sets the value equals to 1. But the order changes. Now what will happen? Now the counter will change to, let's say, 3, and after that 2. This is done by the client 3 and this is done by the client 2. So don't you think the accuracy is going to hamper because of this while loop, this non-blocking IO, because of this event-driven architecture? So the answer is yes, the accuracy can hamper because of this event-driven architecture, but this is only possible when Redis is going to be slow. And Redis is going to be slow in some of the scenarios, like suppose that there are going to be 100 million operations in a single second, then we can say that Redis accuracy is going to hamper a little bit. One more important point is that this event-driven architecture is also used by Node.js servers and Nginx. So it is also one saying that Node.js server is not used with very big projects. This is the biggest reason, because if there is going to be a massive load. Now let's move to the third point. So Redis is a data structure system. What do I mean by this particular sentence? So Redis stores the data in a form of string, integer, list, and many more. We are going to see them. So in a normal case, like if there is a string, so Redis will store the value, let's say key, and the value is going to be string. If it is going to be integer, Redis is going to store the value key and the value is going to be integer. Now there is one question for you. Like suppose there is a one value equals to key. It is in string, of course, and the value is going to be 123. And it is in double quotes, like it's an integer value, but it's in string right now. How is Redis going to store it? Now let's move to the third point, list. So in Redis there are multiple kind of lists. So first point is zip list and quick list. If the we can just take a simple example. If the data is less than 512 or 500, we can just say let's store the data in a form of an array. But if the data is going to be more than 500 elements in a single list, we are just going to use the concept of doubly linked list to store the data, so that we can easily able to traverse. If the pointer is on, like suppose XYZ location, we can just simply insert or delete operations can be fast. That is why engineers have made zip list and quick list inside the Redis, so they can perform the actions on the basis of data size. If that size is less than 500, let's store it in an array. But if it's greater than 500, we can just say let's store it in a form of a quick list. And this 500 is a dummy number. I'm just giving you an example. Same with sets as well. In Redis, suppose in sets, if integer element, Redis has said if there are the elements in the sets that are going to be a proper classes or objects of Java or C++, Redis is going to use hash sets. And if there are only integer elements in the set, Redis is going to use inset. So it is designed in a way so that it can increase the speed of the system. There are sorted sets as well in the Redis. To sorted set supports priority queue, leaderboards, something like that. Now there is one important point in Redis, that Redis supports streaming. Streaming is like a time series database in Redis. So suppose there is a key, and you can just store the value like this is going to be a timestamp, and this is 0, timestamp 1, timestamp 2. So this type of time series database helps to store the state of an onboarding. You can say you can just store the history of an orders. This time series data is also helping Redis to act as a Kafka in many cases. We'll see that as well. So now let's understand the architectures of Redis. So Redis has 3 architectures: single node architecture, master slave architecture, and clustered architecture. We are going to see their pros and cons as well. So let's get started. So first of all, let's discuss single node architecture of Redis. So it means that there is going to be a single Redis and there is going to be a client. Now this client can perform update operation, delete operation, set a value, delete a value, normal operations on Redis they can perform. It can use Redis as a Kafka, rate limiter and anything. But it means that we have only one single node of a Redis is running right now. So let's understand what are the pros and cons of the single node architecture. It's a very simple thing. So the pros are very simple. You have to just install Redis in your EC2 instance or on your machine. You can just install it in with the help of a Docker, and it's very simple to set up. Second point is, it is also very good for small apps, small scalable app. If you're making a small app for your shop or something like that, it's going to be very easy. But there are some cons. I told you that it's a single server. If it goes down, the whole data is going to be lost. Like there is going to be a downtime of the whole system. Second point is data loss unless you use. Okay, so what I mean by data loss? So if you don't use the technique of, if you're not using the proper technique of backing up the data, then data is going to be lost. So now we are going to discuss about the techniques by which we can make a backup, we can restore the data in Redis. So there are two techniques that are AOF and RDB. AOF stands for append only file and RDB stands for Redis database backup. So let's study first of all AOF. AOF stands for append only file. So any operation that is going to perform on the Redis, we are just going to write it on a someone disk. Like you can just say we can just going to write it in a one file. But the thing is, we are going to just perform only insert and set operation. We are not going to write the get operations in this file. We are just going to write the set, insert operation. So we are just going to store all the changes that are going to happen in the Redis, not the get operations. Now there are 3 points in this. So if you are going to write every single operation in a disk, whenever there is a set query, you are going to write it, then it is going to be very safe. If the Redis goes down and again it is going to come up, then Redis can recover all the data with the help of this file because we have all the set operations. But that will make the system slow. If any time there is going to be a set operation, it is going to update the data in Redis, and now it has like an overhead also that it has to write it in the database. So it is going to be a safest process, but it is going to like hamper the speed a little bit. Second thing is every second, that is a default setting of Redis. So what happens after every single second, Redis is going to perform all the set operations. It will just figure it out what are all the set operations performed in that second, and then Redis is going to write them in the in that file. Then the third option is OS, and what you can do, you can just go to the Redis configuration and you can choose the best option according to your need. Now let's understand the Redis database backup. So what happens? Redis saves all the set commands again in this dump.rdb in every 5 minutes. Suppose like there are all the set operations are going to happen in the 5 minutes, and then after that Redis is going to store all the set operations that perform all the queries in one dump.rdb in every 5 minutes. But there is a small flaw in it that what happens, suppose that if Redis goes down, so what will happen, you can just recover all the data, but you will just able to you will just lose some fraction amount of 5 minutes of data in there, because at that time the file was not created, like last 5-minute file was not there, so you will just lose that much amount of data. But if the data is not necessary, then it's fine. But if data is very much important, you can just simply go with append only file. Now you can also change the setting as well. You can just in every 5 minutes you can just change it to every 1 minute as well. If you want to like save less data, you can just go to 30 seconds too. Now let's understand the master slave architecture with an example. Suppose there is one counter variable, and this client is going to update that like if the client wants to update that counter variable, so what will happen, client will send the set request to Redis, then the value is going to be 2. If the client will set the value to 10, then the value is going to be 10. Whenever the client sends the set request, it means wants to change the value of a counter, it will goes to master. So master, what will do master do? Master is going to change the value. to and master is going to change the value in the Redis, because let's say understand it's a simple Redis and master will just referring Redis as a master, and Redis in the value is going to be changed. Now what we have done in a master slave architecture, we connected this Redis with other Redis servers as well. Okay, and we name those servers as slave. So we have now one master and 3 slaves. Whenever clients are going to get the value of the counter, whenever clients are wants to get the value, the slaves are going to respond. But whenever we have to set the value, only we can set in a master. And what will happen? Whenever there is a change in a value of a counter, the master is going to update them, all the slaves. Master will tell all the slaves that I got this value set equals to 10. Master will say I got a new value counter set 10, that means that update the value of counter 10. Then the same query will run in the slave 1, slave 2 and slave 3. Then the value is going to be updated on all the slaves. And suppose at the runtime, like a client is asking the value from slave 1, and the value is going to be return 10. If you have a read heavy system, this architecture works pretty well, because you don't have a load on one single server, because there are many slaves to perform the action and any of the slave can return the same value. There is one important point: if master goes down in any scenario, so what will happen? Any of the slave is going to be become one new master, and there is again going to be follow the fashion of a master slave. Now let's understand one problem in this master slave architecture, that I told you that the value of the counter is going to change in master, and then master is going to update the value in slave 1, slave 2 and slave 3. And let's say there are 10 slaves. All the operations are going to happen in a single threaded fraction. So what will happen? First of all, the value is going to change in the master, and now the value is going to started changing in the slave 1, slave 2, slave 3 and so on to slave 10. And my client started asking the value from slave 10. In that scenario, what will happen? I will get a wrong value of the counter, because slave 10 is still not updated. But we have updated the master, but slave 10 is not updated. So what will happen in that scenario? It sometimes happen that you will get a wrong value in that scenario, and that value is going to be updated in next 5 milliseconds. If you have a lot of slaves, so just keep in mind, don't make lot of slaves, and it can create an issue sometimes. Now let's understand what is going to happen in future. There's going to be a little change. We'll consider a successful write operation only when we also write in X number of slaves as well. So suppose you set the client send a set request, it will reach to master. So first of all, like previously what was happening, we'll just saying that if we write in master, we'll consider it as a simple set request. And what will happen in that case? If we now what we can do, we can just set one configuration. We'll consider a successful write when we update a master and one of the slave is also updated. Then we are going to say that it is a successful write. This will solve the problem of data inconsistency. But the problem that we are going to face, that it will like hamper the speed of Redis a little bit. Now let's understand the Redis clustered architecture. So let's assume that there are 30 keys. So what will happen? In the clustered architecture, there are going to be small buckets like 0 to 10, 12, 11 to 20 and 20 to 30. So what we are going to say, if the key value is going to lie between, I'm talking about the key value. If the key value is going to lie between 0 to 10, it will go to master 1. And of course, in that scenario, master and there are going to be properly master slave architecture. Here also master slave architecture. Here also master slave architecture. So what I'm saying, if there is going to be a simple, if the value of the key is going to lie between 0 to 10, I'm going to say it will go to master 1. If the or you can just say Redis server 1, and if the value is going to lie between 10 to 20, it will go to master, or you can just say simply Redis 2 or a master 2. And if the value is going to lie between 10 to 30 or 20 to 20, it will just go to lie between master 3 or Redis 3. Now, how are we deciding these value? So Redis is just given one number 16384. Whenever you get a key, we are just going to pass that key into a hash function, and after that we are going to modulo with 16384. And after that what we'll get? We'll get some sort of a number. like suppose this is the key name Apple, and what we'll do, we'll just make a hash out of it, and suppose we get a value of 8000. In this case, the value of Apple will go to the second master. If the value is going to be like suppose 13,000, it will go to the third master. What will happen if we added one more server to this clustered architecture of Redis, and what will happen if we delete one, like if one of the masters goes down, what will happen in that scenario? So let me just solve this doubt for you. Suppose the value of m is 24, so all the three cluster are going to have the value of 8, 8 and 8. What will happen? Suppose if there is a new cluster is added, now the value is going to be 6, 6, 6 and 6. Add into, so whenever new server is going to add into a Redis clustered architecture, what will happen? So previously it was holding the data between 0 to 8, now it is holding the data between 0 to 6. Same with the second one, it is going to hold the data between 6 to 12. Previously it was holding the data between 8 to 16. Here it was holding the data between 16 to 24, and here it will hold the data between 12 to 18. Now these data like 0 to 6 and 6 to 8, what will happen? Two data I will send it here. In this scenario also I will just send some of the data, and here also it will going to send some of the data. So in that scenario, what will happen? Redis is going to balance itself. Whenever a new server is going to add it, it is going to balance itself. But remember one thing, whenever a server is going to be deleted or let's say goes down, then there is no balancing going to happen. What will happen in that scenario? If the master goes down of any of the particular node, like just say if this goes down, so don't worry, there are going to be slaves. Any of the slave will become a master. So it will not happen in the Redis cluster architecture that any of the particular node goes down. Any of the slave will become a master in that scenario. There is one important thing. For using the Redis clustered architecture, you need some smart clients so that this hashing can be performed at the client end as well, so that it knows very well that on which client you have to make a get call, on which client you have to make a set call. So it is going to be performed with some smart clients like Redis in Java and IO Redis in Node.js and Redis py cluster in Python, and there are many more, and you can just go and study them. So now let's understand a hotkey problem of Redis, and it is very famous problem, and I think many companies have faced this issue. So there is a client, and there are let's say 3 masters, and there are going to be slaves as well. What is going to happen? Let's say master 1 holds the value between 0 to 10, master 2 holds the value between 11 to 20, and master 3 holds the value between 20 to 30. Let's say two number of key that is in the master 1, because it is lying between 0 to 10, it's a hotkey. Suppose you have a billboard and you are going to show all the movies, and like the 2 key shows all the latest movie. I'm just taking any example. So it is a hotkey, and all the important data is in this, like in the second key. So most of the time what happen, whenever there is a get call, it usually come on the second key, but the load is going to be too much for this hotkey. So what can happen in the future if the load is too much, that particular slave or that particular node of this master slave can go down. So the solution is pretty simple in this case. If you know that this movie global is an hotkey, let's not save it like this. Let's do something else. What we can do, we can just simply do movie global 1, movie global 2, and if then we have to store the data in a movie global 3, what will happen? You just put the value here is like previously hotkey was movie global. Instead of saving it like this, let's save it movie global 1 here. Here we save it like movie global 2, and here we save it like movie global 3. We saved it like this. Now what will happen? Whenever the request is coming on any of the client, and if they figure it out that it is a hotkey, then they can just go to any of the slaves and they can just find the value. They really know that the hotkey is going to be movie global. They have to just append any number like 1 or 2 or 3. If they figure it out, okay, then the problem is solved. So by doing this, now we know that traffic is going to be divided, and we just solve this problem. So that is why we can just use the custom concept at our code as well, how to handle the hotkeys, and that is how we can just solve this problem. Important point to remember is that we are manually handling this problem, but this is a problem in the industry. But Redis is not providing any support for it, because their Redis is not meant to solve this problem of hotkey. Redis is meant to solve the problem of speed. Okay, hotkey problem was solved manually by the company itself. They figured it out what are the hotkeys, and they divided traffic in on the different slaves on the different servers. Now let's understand the topic of expiration in Redis, or you can just say time to live or TTL. So what happened? You can just set a value like set user 10, 24 and ex10. It means that the value is going to be expire after 10 seconds. So Redis supports this functionality. You can use this functionality for OTPs as well. Suppose if you want to say that I send an OTP and it is only valid for 60 seconds. After that, what you can do, you can just delete the OTP from the Redis, and then the OTP is not valid. How it works internally. So Redis is going to run a cron after every 100 millisecond. So I just told you that while loop. So what is happening? Think about it. So first of all, let's say there is a set operation. Again, there is going to be set operation. Normal clients are doing these set operation, and then again set operation, and now internally what will happen? Redis will also running a cron in between. Set operations, cron, get operations, crons. These are the operations. This while loop is running, and all the operations are going to be performed in a single threaded. But this is a true that Redis is running a cron in every 100 millisecond. But think about it. Like suppose there are like millions of keys that are going to be there, and that are going to be deleted. Okay, so it can be an issue that Redis will get like lot of keys and now they have to be deleted. So Redis solve this issue. Redis is going to only pick 20 keys at a time. Redis is going to first delete the 20 key, and the next time when again it will find the keys, like suppose there are 100 keys, so Redis is going to just delete the 20 keys. Now again when the cron will run after 100 milliseconds, now Redis is going to delete more 20 key. So there should not be an overhead on the main thread on the set operations or get operations. Only 20 TTL keys are going to be deleted if the time to live has come now. Now let's understand the Redis eviction policy. This is a case when Redis space is going to be full, or you can just say the RAM is going to be completely full and we cannot store anything else. Then how Redis is going to be react when the space is going to be full? Let's understand this. First of all is no eviction. If you set this particular property in Redis, no eviction, so what will happen? Suppose the RAM is full, or you can just say there is no space left in RAM. Then what will happen if you choose the configuration of no eviction? Then it means that if you just do any of the set operation, Redis is going to give an error that there is no space and like nothing can happen now. You have to just manually delete the data. If there is a TTL set in the keys, then if the keys are going to expire, then you can just further save the key. Otherwise, you will just get an error. Second point is all keys LRU. So it means that if keys are going to be deleted in a form of a least recently used. If the keys are very old and they are not in use right now, they are going to be deleted first. So suppose if there is a set call coming, so Redis is going to figure out the least recently used key and it will delete that key and then insert our new key. This is how Redis is going to do it. Now let's move to the third point, volatile LRU. So volatile LRU say now you have to delete the keys that are least recently used, but we have to delete only those keys that are associated with TTL. So we are not going to delete the permanent keys. We are just going to delete the keys that are having the TTL, or you can just say we are just going to delete the temporary keys. So in those temporary keys, we are just going to figure it out which key are going to be a least recently used. In the temporary key, which key is not in use right now, we are going to delete it first. Fourth point is all keys random. It is pretty simple. Any of the random key you will just delete whenever the new set call is coming. You are just going to delete any of the random key so that we can just store the data. Volatile randoms, again you are going to delete any random key from the TTL, all the keys that are come under the TTL, or you will just say time to live bracket. So suppose there are 7 keys, 3 are coming under the TTL bracket. So you will just say delete any random key from these 3. Sixth point is volatile TTL. It is simply saying that delete the key that have the shortest time to live. That time is going to expire soon. So delete that key. So suppose there are keys. So let's say there are 3 keys. Key 1 without an expiry. So what will this configuration do? Volatile TTL will not touch it. Now there is one more key. Let's say key 2, which is having the TTL of 60 seconds, and the third key is going to have the TTL of 30 seconds. So in this case, the 30-second key is going to be deleted because we choose volatile TTL. It is going to delete the key that is going to have the shortest time to live. I want all of you to think one question here. So suppose that Redis is completely filled, or you can just say RAM is completely filled right now. At that time, you are going to perform a set operation. So don't you think it's a very overhead right now for Redis, because now it is going to perform a 2 operations. First of all, it's going to delete a key, and again now it's going to set a key. Previously, Redis have to just set a key. Now it has to perform a 2 operations, and this is going to happen every single time. So what will happen in that scenario if the RAM is full? Redis is going to slow down, or do you think Redis have a solution for it as well? So think about it and mention me in the comment section that what will happen in that scenario. Now we are heading to the last part of this video, and we are going to understand applications of Redis. So first of all, let's start with a simple application. Redis is a key value store. So usually what you can do, you can use the Redis as a simple database. You can just simply store the value as key value in Redis, and it's pretty simple. What happens, there is a, like, you can just use a Java client, and whenever there is a set call internally, internally Redis will run this command set. Let's say this is going to be your key user 1001, and the value is going to be savage, and like someone will make a get call, then the command is going to be get, and it is going to be user 1001, and the Redis is going to return the value. You can just simply use it like a database, or you can just say Redis key value store. Second one is very common example. Redis has a distributed logs. So now we are using a microservices, and this is a common scenario. What happened, like there are two services with different databases. You can say first service is using MySQL and second service is using MongoDB, and they both have a common key. Let's say log 10. You can just say, like, simply say there is a common key, let's say 10 in both of them, and you want to log them. What you will do, you will just put a log by the first service, and in the MongoDB you can just simply write the code. If the key is logged in Redis, you will perform an action, otherwise you cannot perform an action because that key is not logged by the first service. So this is a simple example of the distributed log. Now let's understand how you can use Redis as a rate limiter. It's pretty simple. So let's say that in your code it is simply written that a user can hit only 30 APIs in 20 seconds. Suppose this is the use case of your rate limiter. So what you can do, you can just set the value user rate 1, or you can just say user rate, and the value is going to be 1 right now, and expiry time equals to 120. And every time a user hit an API, what you are going to do, you just increment the counter in the Redis. Now the value will become, let's say, user rate 1, and after that when you increment the value it will become 2. After that you increment the value it will become 3. And whenever the API is going to be hit, what you are doing in the code, you are just hitting the get of Redis. And what is happening, whenever it will reach 30, you are knowing that the particular user has completed its quota. Now you can just say come after 120 seconds, that, or you can just say try after 5 minutes. So this is how the rate limiting can be also be performed in Redis. And it is an amazing use case of Redis. It can be determined as priority queue or Redis as leaderboards. So I just mentioned one example. So suppose that there is a race going on, and there are some points that I mentioned it here. Suppose that K player is having 20 points right now, P player is having 10 points, and S player is having 5 points right now. So in the Redis, what we are going to do, we are not going to use a simple queries right now. Now we are going to use some advanced queries. So now if we want to use Redis as a leaderboard, we are going to use Z-add. Suppose the value is going to change. Now the value is going to change S is going to come at the first position, K is going to come at the second position, D is going to come at the third position. Like every time the value of the score is going to change, we are just going to update into the Redis with the help of this z add command. Now internally what Redis is going to do, Redis is going to maintain one priority queue, and it will figure it out which is having the maximum value, and it will put it directly into the it will directly put it into the first position. This whole operation that Redis is doing, it is going to, like, we can just simply say it as a max heap, and Redis is also performing internally in log n time. Now let's understand all the commands that Redis is providing. So z add is used to maintain a priority queue. Now there is one zre rank. If you are watching a MotoGP race and you wanted to figure it out, like who is on the first location right now, you can just simply say zre rank, and it will give you the first it will give you the first spot right now. I wanted to know the range who are on the top 10, so you can just say zre range 1 to 10, so it will give you all the all the drivers who are running between 1 to 10. If you want to figure out the range between 5 to 10, it will give you the range between 5 to 10 very fast. If you want to figure out the scores, so just pass the value of the name. You will say zre score. You can just pass the spot. I need the score of the first position. It will give you the score. Zre's name, you can just pass the name, and it will give you the score. Now let's understand how we can use Redis as Kafka. So I just made one simple example that there is one restaurant, and there are 3 users wants to order some food and coke, and then what will happen, this guy is taking an order. So in Kafka, do you know, like, there are consumer groups. So the first consumer group will say, let's say it will make food, and under the consumer group is going to solve the problem of drink. Now for solving this problem, Redis provide an amazing functionality of xadd. Bucket is going to be divided on the basis of the type. So the type is going to be food, or the type is going to be drink. Type is food and type is drink, and this particular thing is order. So let's say the first order is going to be in the type food. It will go into the food bucket, and the ID 1 item burger 2. So let's say the ID is going to be 1. It's going to be, like, you can just say that it is a JSON. So it means that the first user ordered 2 burgers, and the second one, like the second person, or you can just say first person, similarly ordered 1 coke. So what will happen? Order of 2 burger will go to the food group, and the order of the coke will go to the drink group. This is what is happening. Now try to assume that this is all happening in a code. So we have the 2 separate microservices to solve this problem. We have a separately food service, and we have a separately drink service. And now what are these services doing? Whenever they are getting any order, it means that whenever something is going to come from the producers, or you can just say from, like, if they are getting any order, what will happen? They are going to consume them. So suppose what is happening, if we get a 2 burger order, the food service is going to take an action on it, or, like, let's say food service is going to make 2 burgers for it. So they are going to run this particular query, x read group food. So they are reading from the food group and consume 10 data at the same time. They are going to consume the 10 data. They are reading from the food group. Similarly, drink. Now let's understand how you can use Redis as a pub sub. So let's say you have a stock service, and if all the users who are having the Infosys stock are going to subscribe for the Infosys stock. So let's say if the Infosys stocks goes down, this is the code written in, like, the stock service. So suppose, say, if the Infosys stocks goes down, like, say 2500 rupees, then you can just simply say, then you have to publish a notification to all the users that are having Infosys stock. So what will happen? So let's say it goes down to 2500, then the stock service is going to publish. Then what will happen? All the users that are having the Infosys, so they are internally subscribing to this Infosys stock, or you can just say Infosys topic, and they are going to receive the notification. This is how the normal pub sub is going to work. You can just achieve this particular thing in the Redis as well. So in the Redis, it provides the keyword publish. You can just simply use the publish in Redis, say Infosys alert, my key is Infosys alert, you can say Infosys crash. This is done by the stock service. So stock service, what is the stock service going to do? Stock service is going to publish on this particular topic, Infosys alert, Infosys crash. This is going to be the message. And all the services, let's say there is a certain service, these are the user 1, user 2 and user 3. This is my notification service, and that is subscribing that particular topic. Which topic? Infosys alert. And now it knows it very well in the databases that this Infosys alert topic is going to be connected with user 1, user 2 and user 4, because user 3 did not have the Infosys stock, so we have to send a notification to that particular user. This is how the pub service is going to working with the help of the Redis. Redis is going to provide this keyword internally. Now let's understand Redis as geolocation store. This is an amazing point. So suppose Redis provides this geo add, lat, long and name. You can store the latitude and longitude of any place. So what you just use the keyword geo add, and you can just pass the latitude and the longitude and the name of that place, and this is how you can store the values in Redis. So suppose this is the point, okay, that the user is standing, and this is the Pizza Hut, McDonald's and Domino's. Okay, these are the 3 points. Suppose if you want to figure it out which is the nearest restaurant, so you can just simply say geo search, or you can just use the geo distance. If you want to figure out the exact positions of all the Pizza Hut, okay, so Redis can provide it. If you want to figure out the nearest 2 restaurants, so Redis can provide it. Now let's see how we can use Redis as a bloom filter. So first of all, we have to understand what are bloom filters for that. For Instagram usernames, or let's say Gmail username. So suppose you passed a username and it will say this username already existed. This all is happening very fast. So Instagram don't pass the complete username and search in a database or in Redis. What they do, they internally run the algorithm of bloom filter and try to figure it out that this username exists or not. So let's understand it, how Instagram is doing it. So I just mentioned it here, like say 3 names, Savage, KP and Dart. So let's say what we are going to do, we are just going to pass these values in some sort of a hash function. We are going to pass these value in multiple hash functions. So I pass this word Savage in, let's say, 2 hash functions, hash 1 and hash 2, and my bucket size is going to be 10, and we get the value 1 and we get the value 2. So what we are going to do, we are just going to go to this particular array and we are going to just change the value from 0 to 1 for 1 and 2. Now for the KP, let's say again we pass the value in the hash function, we get the value 3 and 4. Same for the Dart, we are going to change the value in 5 and 9. I just told you how we are going to fill this array. Now let's see how Instagram is doing it. So suppose a new person come, let's say Salman Bhai. This is going to be a username. Again we are going to pass it with the hash 1 and hash 2. We get the value 3 and 9. In this case, what is happening right now, if we get the value 3 and 9, we will see to our array and it will figure it out. 3 and 9 value is 1 right now. It means that Salman Bhai will get an error that username already existed. So the thing is, if Salman Bhai is going to get an error 3 and 9, but this is a case of a false positive. We don't have any username with Salman Bhai in our database because we have the name Savage, KP and Dart. So Salman Bhai is still getting an error. Okay. Now let's came to the second example, that is SRK. Suppose SRK is going to provide a value. Let me just change it to give you a wise example. Let's say 0 and 9. So what is happening in the 0 and 9? 0 we know for sure that it not exist. 9 is already existing. So one of the hash is saying that this value is not existing. Okay. So it is a case where we can say that SRK, we can make this particular user because one of the hash is empty. So we can just for sure we can say that this username is not existing in our database or in Redis or in our bloom filter. We can just make this user. So SRK we will consider. Same with Sushant, we are getting in the two hashes right now, 8 and 10. Their two hashes are saying that this value is not existing in our Bloom filter array. You can just make that user. This is a perfect case. So now let's see how we can just solve this whole problem with the help of the Redis. So Redis just provide this amazing feature bf bf.add. So in this you can just pass the username savage, bf.add username kp, bf.add dart. This is the adding functionality, and if you want to just check it, so you can just simply check with the help of the bf.exist, bf.exist. So Salman bhai will get an error because of the Bloom filter. In the scheme of the SRK, what you can do, you can just go to a database and just make a surety again. In the Sushant, it is completely sure that this is not existing in our database, and you can for sure make this a user. So this is it about the video, and thank you for watching me, and I hope that you learned a lot, and bye bye.